Hello. Let me explain you now uh, serial data communication in 8051 microcontroller. So we will see serial data communication now, where we will transmit data high high to 8051 serial port, that is an ASCII data transmission, what we study now. Let me explain you the program first, then I will tell you where to see the result and how to observe whether the data has been transmitted serially or not. So this program is to configure 8051 microcontroller to transmit the data. So I am using to transmit the data high, HI high. So I am transmitting only 2 bytes, so high. We can enhance this program for more number of characters to be transmitted, so that we will illustrate in simulation. The first instruction of the program is move tmod with 0 hash 20h. So what this instruction move tmod comma hash 20h will do, as I told you in theory classes, serial communication also involve timer operation for transmission. We have 4 modes of timer operation: timer 0, mode 1, mode 2, mode 3. So all the 2 timers, timer 0 and timer 1, can be operated either in mode 0, mode 1, mode 2, and mode 3. There are some limitations. Of course, mode 1 as well. But to be operating in serial communication, uh, most of the time we use a timer 0 or timer 1 either in mode 1 or mode 2 serial communication. Different modes of serial communication, that is serial communication mode 0, serial communication mode 1, mode 2 and 3, we have already discussed in the theory class and previous sessions, and that recording is also available. For more information, you can just refer those recordings. So first what we do is we initialize timer 1 in mode 2. For initializing timer 1 in mode 2, the tmod register, so tmod have 8 bits, as we know, we have seen. In that 8 bits, lower 4 bits are related to timer 0, upper 4 bits are related to timer 1. I consider the upper 4 bits. Out of those 2 upper 4 bits, first 2 bits are for mode control. Then the third bit is C/T bar, counter or timer, and finally gate was there. Gate will be 0, counter and timer bit will be 0. Left out will be. Since it is mode 2, we give mode 2 status bits as 10, so we got that as 20. That is about first instruction, move tmod comma hash 20h. Then the second instruction is used to load the content of higher time. Since I am using timer 1, so I have to use th1 with -3. -3 is nothing but fd, the value to calculate, the value for the calculated amount of baud rate. So here we are using baud rate of 9600. So if I want to half the baud rate 4800, obviously discount -3 will become -6. So this I have already discussed, and we have gone in depth of calculating the baud rate in the previous sessions. So these two are the initialization of timers, in which mode are we going to use for serial communication. Then we have to decide the mode of serial communication, which mode of serial communication we are using. So we are using SCON is loaded with 50H. which is an 8-bit auto reload, one start and stop with the receive enable mode. So these three are initialization for timer operation in serial communication mode. Once the initialization of the loading all the status bits are completed, then we start running the timer. We use the instruction set bit TR1. So set bit TR1 will start serial communication, and what is to be transferred is the data we are considering ASCII data H here loaded into accumulator. And as I have told you, we have discussed in theory classes, whatever data you want to transfer to external world from 8051 should be stored in SBUF. So I want to transfer this data H to external. So what has to be done is this H should be stored in SBUF. So I cannot store that directly in SBUF. So I copy it to accumulator. Then from accumulator, I call a subroutine called as transfer, a call trans. In that a call trans, what I do is I load that content into SBUF. From SBUF, it will go out of the serial port. So this is what happens. So load the value in accumulator, load the data in accumulator, then you call a subroutine. This subroutine will transfer that data to a buf of SBUF. From SBUF, it will go out of the microcontroller. Once the operation of transmission is completed, then we know that the transmit interrupt flag is all set. When the transmit interrupt flag is set, it indicates that transmission has been completed. Then we clear the transmit interrupt flag and we come out of the subroutine. When I come out of the subroutine, then the processor will point to this instruction where, so let me change it, it will point to the next instruction where I will transfer I. Again, I is loaded into accumulator, so I want to transfer this to SBUF. From SBUF, it will go through serial port. So again, I perform subroutine transfer. So it is a call subroutine. Again, a call subroutine to transfer. So the processor will come here. So here what happens is we perform the same operation, transfer of the character I to SBUF, and we monitor transmit interrupt flag. Once the transmit interrupt flag is 1, it indicates that the transmission has been completed. Then we clear transmit interrupt and we come back again. So here we end the program. So what this program will do, this program will transmit HI, high, is printed on the serial window each time we execute the program. This is what it happens. Now, once we type the program, we save it and we execute and proceed as per the procedure. We have to use certain things. A few things are to be noted to see or to check the result, whether the data is transmitted or not. So for transmitting the data, here is a few instructions to be followed. So here, to use result of this program, so after selecting debug session in the main program, so I repeat again, after selecting debug session in the main program, once we perform debug operation in the main program, then we go to view window. In view, a pop-up will scroll down will appear. There we are going to select serial window 1, and this is the place where we get the result HI be displayed. So then on running and halting the program, we get the display HI in the serial window. This is what is the procedure is. Because we are not going to see the result in any of the memory locations. Since it is serial communication, we have to see the result in serial window. So this is the procedure to be followed for the program associated with the serial data transmission. So let me demonstrate this program. So I have copied that program, or I have written that program as it is to transfer the data I through serial window, and I have just saved this program. So as per the procedure we follow, then we are going to build and rebuild the target. So the target has been built and rebuilt, so no errors were found. Then I go to debug session here. So after going to debug session, then let me execute. So as per the procedure, as I told you, we are going to view. In view, we have to select serial window for serial transmission. We can find here three serial windows, UART 1, 2, and 3. We select 1. I have already done it. I have selected serial window 1 here. So then if I run the program, I should get the result being displayed as high. HI. So let us see. So it is HI there. So let me change it here. So I want this to display as HI. So let me run this reset, and let me run the program here. I run the program. Yeah, you can see, you can observe here, it has been displayed. I will just highlight this where I have got the result. Yeah, you can observe the result here. It is being displayed here high. You can observe. Yes, the data which was to be transmitted serially, here I have used in HI, I have used to transmit only 2 characters. This program can be enhanced, increased in transmitting more of characters as well. So this is a simple program to demonstrate how to transmit the data serially in a serial watch window. Thank you.